All right, so we're starting chapter 1, doing section 1 today, section 2 tomorrow. Section 2 is really quick, so I'm just going to kind of combine them into one assignment. You'll get that tomorrow. Again, we do have advisory, so we are running a little bit short on time today, so we got to make sure that we're on it and moving at a good pace. So linear equations in one variable. A lot of this should be some real strong Algebra 1, Algebra 2 vibes. Okay, so hopefully a lot of this will start to click pretty quickly. What's the big difference between an equation and an expression? Which one? Equation has the equal sign. So the verbiage on problems will be different. Equations are solved, expressions are simplified. Okay, so that's the big difference between the two. Equations, we're solving for a variable. Expressions, we're simplifying. We may end up with a number or several different terms for an expression, but when we're solving an equation, we're finding the values that make the equation true for the variable. Now, this is kind of our general form for an equation in one variable, but we do have others that we'll be dealing with. Ax plus b equals c. A, b, and c can be anything that's real as long as a is not 0. Otherwise, our variable goes away. First degree equation is linear. Okay, so we have an implied exponent of 1. Then when we get into quadratics and stuff, it makes a bigger difference. You guys should know kind of this process when we're solving. We use this addition property or multiplication property of equality, which boils down to we can basically do whatever we want to the equation as long as we do the same thing to both sides. I can add the same number to both sides, subtract the same number, I can multiply the same number, I can divide the same number. We can do whatever we want as long as we do the same thing to both sides of the equation. The goal is to get the variable to be by itself. Now, before we apply either of those properties, we want to simplify both sides of the equations, looking for things like distributive property or combining like terms. How can I simplify the left side of this equation? Add are like terms, 12x. How can I simplify the right side of my equation?
Combining -1.
To give me what? 10. -10. Okay? Alright, so I've simplified the left side and the right side. Now I'm going to use those properties of equality. I have two variables. I need one. How do I move one of the variables from one side to the other? We're going to subtract. We're going to do that inverse operation. And since they're both positive, we're going to subtract. Which one do you want to move, the 12 or the 17?
17.
17, that's fine. Ain't no thing but chicken wing. All right?
I don't want to do a negative.
Well,
it's 2 negative, so it cancels when it's positive.
You can move the 12. You just have to move the 10 after. Okay? So what is 12 minus 17?
5.
-5. Okay? So we got -5 x equals -10. All right? And then how do I move that 5? Divide by -5. It is a positive 2. Okay? Now, I'm taking a quiz, I'm working this out, and I'm a little unsure of whether or not it's wrong or right. How can I check?
Sub it in.
Sub it in. Plug it back in. So if you plug it back in, it should give you a true statement. I'm not going to take the time to work it out. I'm pretty sure you guys can plug that into your calculator and make sure that everything is true. All right? A couple things I want to highlight and make note of because they show up and it makes a difference. Okay? 17x minus 17x equals what? 0. Okay? That's why that cancels out. Because I'm adding or subtracting to get 0. 0 plus anything doesn't make a change, so that eliminates over here. What is -5 divided by -5? 1. 1 times anything doesn't make a change, which is why that gets eliminated, leaving me with 1x equals 2. Okay? Just want to make sure I'm really clear on that. All right? When we're adding or subtracting, our goal is to get 0. When we're multiplying or dividing, our goal is to get a 1. Okay, specifically a positive 1. Questions, comments, concerns here? Okay. Yes. Right there. Okay. So again, these are the steps we went through. All right. The only thing we didn't have was that step 1, which was clear the fractions. It was simplify each side separately. Isolate the variable using our additive and multiplication properties. And then again, we talked about you can check your solution by plugging it into your original equation. The only thing that's different is we have this new step that we'll see in a couple examples, clear fractions. And we're going to eliminate fractions by multiplying by the least common denominator. So we're going to have to remember that step in a minute. We're going to multiply by the least common denominator. All right, so do I have any fractions to clear out of this expression? No. Do I have any distributive property that I could do? Yes. Where? Here and here. This is a negative what? 1. Okay? So 6 minus 4 minus m equals 8m minus 6m minus 10.
Wait, minus m.
Negative 1 times 4, negative 1 times m. The 6 and the 8 aren't being multiplied, they're being added. So this is 6 plus negative 1 times 4 plus m. This is kind of a separate thing. This is additive, this is multiplicative. Okay? Same thing with the negative 2. This is 8 plus negative 2 times 3m plus 5. Okay? Now, can I combine any like terms on the left? What?
6 and 4.
Gives me what?
2.
2 minus m. And on the right?
2m.
Good. Now what?
Let's get 10.
By doing what?
Adding.
Okay. Okay. Add m to the other side. ¿Para cuentas? I hope. I hope. Alright, now. Hey, look, let's make it worse. Fractions. Okay. Who remembers what I said we have to do? Okay. Now, more specifically, instead of getting a common denominator and rewriting so that I can add them, the goal of my least common denominator is to get rid of the fractions. What is my LCD of 2 and 4? 4. The smallest number that can be divided by both of these. Okay? The smallest number that can be divided by both of those. So I have an LCD of 4. Okay? So what I'm going to do is I'm going to multiply everything by 4. Okay? The goal is to get my denominator to clear or to cancel. So we're going to apply this distributive property. Now I'm going to write the multiplication and then we're going to simplify. That's a, even though it may not look like it. So all terms are being multiplied by 4. Our least common denominator. Again, our goal is to get our denominator to cancel. Okay? So we're going to look at, hey, our LCD and then the denominator for each of these. Looking at the first term, what's 4 over 2 simplify to be? 2. So that simplifies, leaving me with 2k plus 1. Okay? 4 over 4 simplifies to what? 1. And then 4 over 2 gives me 2 again. Okay? Now, I wrote a little bit more information than I needed to here, but again, I want you to kind of see that full process, okay? Now, multiplying by 1 here and here isn't going to change anything, so I don't really need those anymore, but what do I have to do with this first term? Still got to do the distributive. 2k plus 2 plus k plus 3 equals 2. And then I just combine all my like terms. Best option I have at this time. Questions, comments, concerns? Let's start the next one together, and then I'm going to have you guys finish it. Okay? So, similar idea, but we're dealing with decimals instead of fractions. We still want to kind of get rid of those decimals. Can you just distribute the decimals? Yes, you can. But when we get to the part of combining like terms, then it just gets a little more troublesome, especially if our decimals have different place values, okay? So to make it easier, we're going to cancel out the decimals in the same way that we cancel out the denominators, okay? What place value is each of these decimals in? The hundredths. So I have 2 hundredths and 4 hundredths and 3 hundredths. So then what is my least common denominator? So I'm going to multiply everything by 100. Well, what's 100 times 0.02? 2. What's 100 times 4 hundredths? What's 100 times 3 hundredths? Just makes it easier numbers to deal with, especially when we get to the part where we're starting to combine like terms. It's much easier to add and subtract whole numbers than decimals. All right, you're going to finish this one on your own.
Because you have the live whiteboard on, we can't do it.
Thank you. I didn't know that. There. Hey. Hey, quit telling me. Learn something new every day. Yeah, go for it. I mean, I'll go through it after. They been sold out. You can order them on Amazon. Target.
Walmart was more cost efficient because I would have got like 50% off.
That's fair. I'm sorry. They're probably sold out.
Well, technically, if you have the coupon, they have to honor a coupon if it's like electronic.
Well, no, mine is the forever coupon. Like,
Forever coupon crazy.
I get 80 to 100% whenever.
Is that a 5-finger discount or like what?
Jordan.
Sponsored by Walmart. That's the first time I ever did.
Alright.
Oh.
Yes, no, I don't know.
Huh?
I just know.
Ellen, what?
30 is, oh, I put P equals 30.
Oh yeah, just the number. Just the number.
Oh, I
No,
put
that's
these
not-
mistakes
Wait,
That's not mathematics.
30? So then I got it right.
30 is correct.
So you put
P
B,
equals 30 then.
Just 30. Just put in 30.
B equals 30.
Yes. Yes, but just put in 30, okay?
It's okay.
Oh boy, oh boy.
Look, man. The score says incorrect, but in my mind, I don't know what that was.
Alright. Questions, comments, concerns?
No, sir. Zero complaints.
So on the quiz, we just put 30.
I mean, quizzes, you write it in, so P was 30, 30, it was fine. Alright, now, every type of question we've had so far is how many answers? One. Okay? That's called a conditional equation. There is one solution. X equals one number. That's it. Okay? That's everything we've dealt with so far. Now we're going to add in a couple different ones. We've got two different types, identity and contradiction. And identity means I can plug in any number for the variable and it's not going to make a difference. Okay? It's going to be the same value. Okay? Which means I have an infinite number of solutions. We'll know it's an identity because our final line is usually a true statement. A lot of times it's 0 equals 0. Okay? 0 is always 0. It may be x equals x. Okay? What you're looking for with an identity is at some point your left side and your right side are exactly the same. And if that happens, that means you have an identity. And it doesn't matter what value of x you plug in, you're always going to get a true statement. Contradiction is our final line is generally something that is a false statement. Negative 15 equals negative 20. Or 5 equals 17. Something that's not true, and that means it does not matter what number you plug in. You're never going to get a true statement. There is no solution. Okay? No solution. It's an empty set. Okay? So what I want you to do is I want you to do your distributive, your combining like terms, and I want you to solve this and see what type of solution we get. Whether it's going to be a conditional, an identity, or a contradiction.
Oh, I have to write my work.
Just some of it at least. Just give me if you don't have a lot of room, you can at least just give me the final line, and whether it's conditional, identity, or contradiction. Contradiction, identity, or okay, the last line, and which type of solution it is. 15 more seconds.
I was right, but I wasn't right.
When I do 3x minus 3x, what do I get? 0. Do I have a variable anymore? No. Okay, so it's not x equals negative 7. I end up with 0 equals negative 7.
You could.
If you move it the other way, you could get 0 equals 7. It depends on which way you move it.
I was questioning. Okay, got it.
But regardless, what's going to happen is I have a statement that is clearly not true. So that means I have a contradiction. Okay? So be very careful when those variables cancel out. All right? What happens when they cancel? All right? What do I need to multiply by here to get rid of my fraction? 3. Go. So here, 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 and here, I'm going to end up with x plus 1 plus 2x equals 3x plus 1. Combine like terms, and I can stop there. What type of solution is this going to be?
That's going to be
An identity. Because the left and right side are exactly the same. I could plug in any number for x, and it's always going to be true. So I have an identity. Okay. Questions, comments, concerns on that? Okay. What do I do first? Distribute.
15x plus 5 equals Subtract 5.
No.
Well, it's not a false statement. X is equal to a number, so it's.
Zero is a number. 0 is a number. Your answer's allowed to be 0. That's okay. I could plug in 0 and I will get a true statement. Okay? 0 is allowed. Just because I get an answer of x equals 0 doesn't mean it's a contradiction or an identity. X can be 0. I divided 0 by 14. So I subtracted 5 here, divided by 14. And I subtracted x here.
Wait, so what's the answer? Is contradiction?
No. 0 is a number. My variable did not cancel out in that process. My variable's still there. That's the difference between this one and the first one. Okay? The first one, the variable went away. 3x minus 3x is 0. Here I still have my variable. There was nothing here that got rid of my variable. It just happens that my variable equals 0. Okay? So paying attention to those two is very important. Alright. Couple quick questions and then we're done for today. Why is so much faster? Yeah, but it's like I struggle to get here in time for first period and we're gonna have. It's a false statement. -5 does not equal negative, or does not equal 2. Contradiction.
So that's right.
In just a few minutes,
Both sides are the same.
will be dismissed
Identity.
to advisory.
Doesn't matter what number we put in, it's always true.
Administrators should report to their advisors' classrooms prior to when they get to the classroom. Teachers will swap with them to the
Thank you.